In this video, we are going to discuss about IIR filter realization. So, in that, to realize a digital system, we can use direct form 1, direct form 2, cascade or series realization, or parallel realization. So, realization is a hardware or software configuration that implements the system. So, the digital filter is represented by a transfer function h of z, may be generally realized into the following forms: direct form 1, direct form 2, cascade or series, and parallel form. There are other form of realization such as lattice, but we are not going to study here. So first we will study the transfer function of the h of z of a digital filter system transfer function, which is given by h of z is equal to b0 plus b1 z power minus 1 plus up to pm z power minus m, divided by 1 plus a1 z power minus 1 plus up to a plus an z power minus n. So we know that y of z is equal to h of z into x of z. So let us consider x of n and y of n be the digital filter input and output. X of n is your input and y of n is your output. Okay, and h of n is nothing but a impulse response, right? So we can express this relation in z domain as equation 2. That is y of z is equal to h of z into x of z. So we are going to substitute the first equation in the second equation. You will get y of z is equal to, this is h of z, this is x of z, not h of z, right? Y of z is equal to h of z into h of z, and the h of z values from the first equation. So if I take the inverse transform of this one, inverse is a transform of equation 3, we will get the difference recursive difference equation. It is y of n. So if I bring the numerator term to the left hand side, so you will get y of n plus a1 into y of n minus 1 minus up to an into y of n minus capital N. That is equal to b0 into x of n plus b1 into x of n minus 1 up to bm into x of n minus m. So this equation I can write, I can implement this recursive difference equation by direct form 1, right? So I can write, so if we see in this way, b0 into x of n, b0 into x of n. Next, z power minus 1 means it becomes x of n minus 1. X of n minus 1 into x of n minus 1 into b of 1. Alright, so if you see the numerator value is something, it is called as zeros, and the denominator value is called poles. Okay, so if I have the coefficient of x, like x of n means that is called as zeros. So first you have zeros, and second one you have a pole. So you can see in the zeros there is no sign change, right? So you will have b0, b1 up to bm. Okay, so and you can see the b0 is multiplied with x of n. So that is why I have that triangle like signal. Okay, so this is called a signal flow graph. Okay, So this is a structure of a direct form one. So and if you see the poles you have minus a1, minus a2 and minus an. So you have to change the, so you should not change that this attack. But if you write it in the y of z and x of z form, so you will get a1, a2 and an. So if you see the if we change it to y of z divided by x of z, you will get 1 plus a1 up to an. So therefore you have to change the sign of that pole, right? If you have a1, you have to change it as minus a1 and vice versa. So this is how you have to connect. So the calculation of for y of n using this form, which will require m plus 1 input state. Okay, and you have n output state. So therefore you require m plus n plus 1 coefficient multiplication and m plus 1 addition. So how many additions are required? 1, 2, 3. M and n value is equal to 2. Okay. So you require 4 additions. And you can see I have a 5 coefficient, right? 5 multiplication coefficient. So whenever more than 2 or 3 delays are required, this particular implementation is very sensitive to finite word length effects. So you can see here it is in the format of y of z divided by x of z. So I have 0.5 and minus 0.5 values. That is nothing but your zeros. So you have to write it like this, like 0.5 and minus 0.5. And the pole value you have to change the symbol, right? So instead of 1.3 you have to write it as minus 1.3 and 0.36 you have to write it as minus 0.36. So this is how you have to implement the direct form 1. So it can be this direct form 1 structure have some following properties. That is, it can be recorded as a 2-0 filter section, which is followed by in series with by 2 pole filter section. So this contains second order. If m and n values is 2, so it is called as 2 pole and 2-0 filter section. So in most of the fixed point arithmetic schemes, there is no possibility of internal filter overflow.